In today's lesson, we're going to be solving for practical problems for systems of equations. We're going to follow these 6 steps when we're solving our word problems today. The first step will be reading through the entire problem. Then we'll highlight the important information and numbers that go with it. Step number 3 will be identifying our variables. We'll be using x and y since those will help us graph these equations in Desmos. Step number 4 is the most important step because we have to write 2 separate equations to represent the 2 different scenarios we're dealing with in the word problem. They'll use the same variables, like I said, x and y. A hint to you is that you want to use the 2 following forms. We use standard form when the total is known and we have 2 different items. Standard form, as a reminder, is ax plus by equals c. We'll then use a different form called slope-intercept form when the total is unknown and we have one rate plus an initial value. That's going to be y equals mx plus b. After that, we solve the system of equations by plugging the 2 equations in Desmos. Seeing where the intersecting points meets is going to give us our answer. We'll just have to write the answer asked in the problem. Always want to answer the question asked. So let's go ahead and get started. Example number 1. A test has 20 questions worth 100 points. The test consists of 2 true-false questions worth 3 points each and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? So again, let's start by highlighting. So go ahead and take out a highlighter. First color, I'm going to highlight everything that was talking about points here. So I'm going to highlight my 3 points each, and that specifically went with the detail of my true-false questions. Like I said in step number 2, I'll just go back to it. We highlight in the important information as well as the numbers. Next number I have here dealing with points will be 11 points each, and that was specifically for my multiple choice questions. After that, the only other number that I have here that's dealing with the points is 100. And that was talking about the whole test being worth 100 points. So right away, just after highlighting those, I can think about what equation I'm going to use. I see that my total is known because I have 100 points as my total. And then I have 2 different items. The 2 different items are true-false questions and then multiple choice questions. Because like I just mentioned that I have 2 different items on this test and I have 2 different categories, I'm going to go ahead and make those my variables. I'm going to make X the first type of question, which is my true-false questions. I'm going to make my Y the second type of question on this exam, this test, which is going to be my multiple choice questions. Now, you could have swapped those, that's totally fine, but make sure you have 1 and 1 and make sure you keep it consistent throughout the problem. So now that I've decided the form, it says I have to use my ax plus by equals c, filling in my a, b, and c. Well, like I said, I'll keep my x here, and I'll replace the a, which is the number that goes with my true-false questions. Going back to the problem, that was 3 points per true-false question. Then I will be adding up these points because I'm adding to the total, and I do know the total, which is 100 at the end, so that's going to be my c of y. In front of my y, my coefficient is going to be the number of points that go with my y, which is my multiple choice questions. That was 11 points per multiple choice question. And like I said, I knew it was equal to the total points of the test, which was 100. Second equation, same idea. Let's go ahead and take a look at any other numbers I have. Remember, sometimes your numbers can be written out, so don't forget about those. So it looks like the last number I have is 20 questions. It states that a test has 20 questions, so I know that's going to be my total again. So again, I have the total known, yes. So that's why I'm going to also write this equation in standard form, my ax plus by equals c. So I'm going to go ahead and have x plus y. I have no other numbers to go in front of my x and y as my a and b, so I'm just going to keep it like this, which makes sense because x is the number of true false questions, which I don't know. I also don't know the number of multiple choice questions, that's what I'm trying to find, but I do know there are 20 questions total on the test. So I'll add the two and total it up to 20. Now that I have the two equations, we go right to Desmos with this. Why I chose to write this equation again is because all these numbers were related to points. Each had a unit of points, so that's why this equation is all about points. The next equation was x plus y equals 20. I got that because that was the numbers related to the number of questions on the test. I knew there were 20 questions total on the test. Some of them were true false, and some of them were multiple choice. Add them up, gets to the total of 20. So at this time, I would pause the video and make sure you have Desmos up because we're going to put equation number 1 in line 1 of Desmos. Then in my second line in Desmos, I want to type in equation number 2. So you want to make sure you have that in and you're following along. Type that into Desmos now. At that time, you want to make sure you zoom out because the point is going to be off the screen at first. The intersecting point, as you see, I can click right on the graph and it gives it to me of 15, 5. So make sure you find the point where they meet. Make sure you find that 15, 5. That's exactly what I'm going to write on my paper. But I can't forget this last step says to use the graphing calculator to graph the systems. That's what we just did. But then I have to answer the question that I was being asked in the problem. As you see, I highlighted above in orange. It states that how many multiple choice questions are on the test. That's actually what I need to answer. I need to think about which one is my multiple choice, and that's when I go to my x and y variables I decided in the beginning. I see that the multiple choice questions are my y. Therefore, that's why I'm choosing the number 5 to answer my question. Of 5 multiple choice questions are on the test. Can't use 15, that goes with my true false questions. And the question at the beginning was asking how many multiple choice are on the test. So that answer is 5. A little sentence, a little brief explanation is great. So, how I'd answer this question is that there are 5 multiple choice questions that are on this test. Starting example number 2 the same way by reading and highlighting. Let's go. Suppose you have $28 in your bank account and then you start saving $18.25 every week. Second color highlighter, because now I have a new sentence talking about somebody else, my friend instead of me, has $161 in his account and withdraws $15 every week. So that's what I'm going to highlight here. I always highlight the number, and I like to highlight any context around it. Anything that's going to say every, per, talking what it's about, units, etc. At this time, we're going to go ahead and define our variables. Well, with this problem, what I'm going to go ahead and have is something changing every single week. Every single week, I saw that I was adding or taking out money on my bank account. So my X is going to be weeks, number of weeks. The Y value is going to be what we're actually getting towards, which is going to go ahead and be the total amount in the bank. I know this because I'm thinking about the information I was given. I was given what I had in my bank account and then what was changing each week. So I knew right away I did not have a total known. So is the total known? Yes. That's why I'm leaning towards this y equals mx plus b format for my equation. I also knew I had the initial value, which was the money in account. That's what I started in the bank account. I do have one rate. That one rate is what's changing, which is the money that's being entered or taken out each week. So that all leads me towards using my slope-intercept form of y equals mx plus b, filling in the slope and the y-intercept of b. So my first equation, like I said, I don't know the total amount of my count, so I'm going to start with y equals. And how I'm going to start this first equation is talking about everything about my bank account. Well, I know for my bank account, not my friends, I started off with $28. That was my initial value. That's the y-intercept to the b value. Then I started saving. Saving is a great indication that I'm going to be adding money. And specifically, the money I'm adding is $18.25. Because that's each week, that's the one that's going to have the X. Because after week 1, that would be $18.25. After week 2, that would double, and so on and so forth. That's going to be my first equation. That 18 and 25 cents is actually going to be my M, which is my slope, to help get that format. For equation number 2, that's always going to be about my friend now. So this is going to be my friend's bank account. Again, we start with y equals because we don't know the total amount in the bank. We know the start was $161. That's our B value, our starting value. Because my friend is withdrawing, that is a great way of saying that I'm taking out money. So a subtraction of 15 each week. So after the first week, I take out 15, then I lose 15 more the next week. Because that keeps changing, that's my slope, that's my M. Now I have the two equations, I go right to Desmos. So you type in equation number 1 in the first line, and equation number 2 separately in the second line. As you see, you'll have to zoom out to see where they meet, because the point they meet is at 4, 101 when you click on the graph like I just did. Going back to our question, I type in the solution, or I put in the solution, but then I can't forget it says to use the Desmos graph to graph the systems. We just did that. Then answer the question. The question I highlighted in orange at the top, which is when will your account balances be the same? So the account balances of your friend and you will be the same at 4 weeks. How I knew it was 4 weeks is because weeks was my X value I defined in the beginning. And that's what I was looking for when specifically relating to the time, the number of weeks. In example number 3, we have one night a theater sold 548 tickets. So that's when I'm going to start by highlighting the first number I see with what unit or label goes with it, selling those tickets. An adult's ticket cost $6.50. So again, highlighting my number and specifically the unit of adult tickets going with it. And a children's ticket or child's ticket costs $3.50. So again, highlighting that $3.50 with what it went with, which is the cost of the child ticket. In all, last number we have is $2,881 was collected. How many of each kind of ticket were sold? That's going to be what the question I answer with at the end. So let's start with talking about the two categories we have here. I have two types of tickets, and that's how I know I'm going to use standard form. But we're going to start with defining our variables. The first type of ticket was adult tickets, and the second type of ticket was child tickets. So since I know there's two types of tickets, I have to separate them, specifically since they are different prices and different tickets. Like I said again, that's going to help us set up our standard form equation. When we write our system of equations, we want to make sure we're using the same units or same situation for each equation. So my first equation is going to be all about anything with the units of money. So I want to relate the situation of money and anything related with money in this equation. Well, I know that standard form is AX plus BY equals C. And we're always replacing the A, B, and C. Well, we know that adult tickets is our X. So that's exactly what I'm going to put in front of X, my price of the adult tickets. In front of my y as my b value, that's going to go ahead and be the cost, again, since it's the cost equation of the child tickets. We'll write it directly highlighted above, was $3.50. Last but not least, I equal to the total dollar amount. The total dollar amount was not 548, that was the ticket amount, but the dollar amount of $2,881. So I knew this first equation had to be relating to everything money-wise here, specifically everything that had a labeled unit of money. For equation number 2, I'm going to go ahead and not look at money now. I'm going to look at the tickets here that were sold. The only information I have about the tickets sold, I highlighted in the first sentence, was that we sold 548 on that one night. What kind of tickets did we sell? Some of our children's and some of our adult tickets, so that's why I have X plus Y. But nothing goes in front of my X plus Y because I don't have any further information besides that some adult tickets were sold, some child tickets were sold, to make 548 tickets sold total. And then we'll break down how many adult, how many children when we look at the system of equations. So then don't forget to go to Desmos now and type in equation number 1 into line 1 and equation number 2 in line 2. You'll have to zoom out a bit because, again, this is a pretty large number, but you see that the two equations end up meeting at 321, 227. I write that point exactly as is onto my notes paper, but then I have to answer the question. The question I have highlighted in example 3 in orange of how many of each kind of ticket were sold. Specifically, X was talking about the adult tickets like we just referenced in our variables above, and Y equals child tickets above. So that's why I said 321 adult tickets were sold and 227 child tickets were sold. Basically, I'm putting the units on my X and Y variables that I defined in the beginning. Last example in our notes is going to be the following. Let's start highlighting, where I have the sum of two numbers being 30. As a reminder, the sum is a great indication that I'm going to be adding the two numbers for this problem. Their difference is 12. Difference is a great indication that I'm doing subtraction here. My goal, my question in the end, is to find the two numbers. Well, I'll start by defining my variables. I am looking for two numbers, so my X is going to be the first number, and my Y is going to be the second number. The first equation I highlighted was the sum of two numbers. Again, the two numbers, the first one is X, the second one is Y, and I'm adding that between because I had the addition above of sum. And that sum was 30. So that's my total amount here. Also, why I'm using standard form of AX plus BY equals C. Then my second equation was going to be about the difference of the two numbers. So that is now taking the two numbers, first number X, second number Y, subtracting them to get the difference total, which would be 12 here. Now I put that in Desmos to find my answer. Again, as a reminder, for the first equation, I knew that it was going to be the sum, so I placed that between my two variables. I knew the second equation had to be all about the difference, which represents subtraction, hence why I put the subtraction between my two variables, my two numbers. We go ahead and put equation number 1 in Desmos in the first line and equation number 2 in the second line. Again, zoom around to see where they actually meet. Make sure you get that point of intersection, 21, 9. Putting that point down in our notes and then actually answering the question, I highlighted above in example 4 in orange that we need to find the two numbers. So the two numbers were 21 and 9. First number was 21, second number was 9.